So this is joint work with Adrien Raizonville, who is at Télécom Paris in Saclay. And this is going to talk, well, that's a theoretical paper that is going to talk about algorithmic explainability and obfuscation under regulatory audits. So I think, yeah, regulatory audits don't need a definition, and I give a more precise definition of explainability in a second, but just to fix ideas, we will define very broadly explainability in this paper as the ability for human beings to understand whether an algorithm is engaging in misconduct or not. Okay? If an algorithm does a misconduct and is purely unexplainable, regulators can't do anything, while if the algorithm is explainable, then a potential misconduct will be easily identified by the regulator or by the firm itself. Okay, so explainability is just yeah, the ability, well, a characteristic of the algorithm that makes it so that it can be explained in human terms. Classic introduction for algorithms. So I don't have to convince you here that algorithms are everywhere. Decisions are increasingly taken or advised by or guided by algorithms. We are going to start in this paper from the assumption that we need them. Okay, it's still a good thing. Well, we know that algorithms allow to reduce significantly transaction and search costs. They make much faster decisions that are arguably less error-prone than human decisions, at least in some sectors. It also allows to create totally new services that you wouldn't be able to do without algorithms and AI. So here's an example. I'm going to take that as a lead example, but really the model will be very general, of HireView. So HireView is an AI hiring system that essentially consists in running interviews instead of human beings. So you will have online interviews with a machine that's going to basically pre-screen you for the interview process. In particular, what they do is, of course, to analyze the textual answer that you give, but also they will analyze the facial expressions, the tone of the voice, how articulate you may be, in order to give a recommendation. So clearly, this very much illustrates how algorithms can be incredibly more effective or efficient or fast than humans, but this doesn't go without issues, as we are going to see in this presentation. So, first observation was that we need algorithms, and we are going to use two specific observations for this paper that are going to be the key assumptions of our model. The first one is that when it comes to machine learning, very often more explainability means lower performance, at least when you run cutting-edge algorithms. So it's actually a pretty well-known fact in data science that usually the best algorithms, or the ones are able to achieve complex tasks, are very unexplainable. Okay, so this is a illustrative graph from DARPA. So that's a research center for data science of the Ministry of Defense in the US, who are very much at the forefront of this discussion about explainability. And you would find other sources showing the similar stuff. So for example, deep learning, which is arguably one of the most accurate techniques these days, is very little explainable. That is, you'd have a lot of difficulties to actually explain why the algorithm came up with a specific solutions. Usually the solutions or the predictions are going to be excellent, but as to why, you'd have difficulties explaining it. And as you go to simpler stuff, then you have more and more explainability, so basic regression will be clearly around here.
So the main drive is about explainability?
Absolutely. And how to promote it, yeah.
Okay.
Sorry. So indeed, that's the first observation. Second observation, algorithms may misconduct. Okay, I'm not going to challenge that in that presentation. So in the case of AI facial analysis, they had to backtrack on this device because of concerns that the AI algorithm might discriminate. Indeed, it's very difficult to ensure that the algorithm will not discriminate because it's a black box. And as long as the objective function is to just maximize matches, it might very well indeed reproduce discriminatory biases. Yep.
guess a stupid question because I have no clue, but...
There's no stupid question.
But, I mean, let's say, human resources do use this type of algorithm to hire people. This is true.
This was the intention, then it was, no, it was, they backtracked on that, so they did not implement it.
Okay, but they were willing to do it.
Yeah. Yeah, well, and then there's human supervision, so from the legal perspective, probably the legal supervision to the, in the US. Yeah.
What's the name of the firm again?
HireView. But well, I could have taken other examples. So this is just for discrimination biases, but we've seen in the previous talk that there is increasing concerns about well, collision or supra-normal prices, biased recommendations as well, and market manipulations of any sort, which is very much of concern. So when you take these two observations together, so performance means low explainability, and algorithms may misconduct. Well, this creates clearly a suspicion that AI algorithms may take socially undesirable actions, even without their makers knowing that. Okay, so autonomously they would take socially undesirable actions, even though they are not programmed for that, not specifically for that. So there is more and more discussion for greater transparency and more regulation. So, well, here is one quote from Vestager that says that when businesses decide to use an automated system, they will be held responsible for what it does. So they had better know how that system works. So really this, the relation between the misconduct and the transparency is very intricate. So this has taken form, well, this starts taking form in the three packages from the European Commission, for example. The Digital Markets Act that defines very clear rules for how we may audit algorithms, which is going to be our topic of study in this talk. The Digital Services Act also puts a lot of stress on the ability to explain the decisions and the predictions of the algorithms. Sorry. And so those ones are expected to be put in place in 2023. And the AI Act also has this intertwining, but there's more of a focus on privacy specifically. Okay, so we define explainability here as the extent to which a misconduct that an algorithm may have taken may be identified by humans. So the research questions it's very simple. The broad one is, can a regulator limit algorithmic misbehavior through the audit of that algorithm? That's going to lead us to answer two subsidiary questions. The first one being, how does these audits affect the firm's investment in explainability? Okay, you've seen in the graph before that essentially investing in explainability makes your technology less efficient. So it has a cost in the form of a less good product, right? So that's the first question. So will it affect explainability? And also, when it comes to implementation of regulation, should we force firms to actually disclose their explainability levels? Okay, should you force Google to actually say, okay, we are using deep learning or we are using random forests, and should you force them to be a bit more transparent about the characteristics of their algorithms? So, relation to the literature, so there's a very wide literature on algorithm misconducts, and in particular, literature on supranormal profits, sometimes referred to as collusion because it really looks like so. Well, we've mentioned quite a few of them already. Some concerns, of course, about discrimination. Okay, so the delegation of discrimination to algorithms is also a concern. Also concerned about self-preferencing when it comes to recommendation algorithms. So, well, we are going to contribute to this literature by just offering some regulation to that. Strangely enough, it will have a connection to the economics of crime, where you have a few papers that show that indeed, if you want to commit a crime or if you want to engage in illegal actions, you may want to obfuscate your actions so as to make it less visible by the police and you can escape. Okay. Here are additions here. So here explainability or obfuscation would be a tool to escape monitoring. Here our additions here is that explainability also allows you to know better your own algorithm. Okay, so if you know well your own algorithm, you're going to be more able to comply and make sure that there is no discriminatory bias in the first place. It also relates to the literature on self-regulation. We have a few papers about environmental investment. Here our contribution is really that the explainability here, so the obfuscation you may put in place, actually also affects the efficiency of the auditor, of the regulator. Okay? So this is where we differ from this literature. Okay, so the model in a nutshell, so we study a regulator who seeks to emulate firms' compliance to a socially desirable strategy, okay, through the threat of costly and imperfect audits. Okay, so this is quite classic. It comes with a classic trade-off as well, that the firm will trade off the cost of improving compliance. Okay, so making internal audits, for example, prior to regulatory audits and putting the technology in the market. So trading these costs against, of course, a lower probability of getting caught into misbehaving. In the model, we'll have that to make compliance more effective, okay, firms may invest in explainability. So the explainability is a two-edged sword. On the one hand, it will help the firm to understand its own algorithm. Okay, and it will therefore reduce the marginal cost of compliance, because if you know well your algorithm, it's just easier to audit it yourself. Okay, and to understand whether it's misbehaving or not. If it's misbehaving, correct it. On the other hand, and this is really a particular aspect of explainability, it also increases the regulator's understanding of the algorithm. So if there is no audit by the regulator and your algorithm is transparent, then you're more likely to actually get a fine. Okay, we'll have the hypothesis that you get a fine internally if the regulator can prove that you were misconducting. And for this, it needs to understand that at a minimum level the algorithm at stake. We are going to compare two regulatory regimes depending on whether the regulator observes explainability before auditing or not. So that's going to be technology-specific regulation or technology-neutral regulation. Technology-neutral is when you don't know beforehand what sort of technology is being implemented and therefore what sort of explainability level you may face. So the findings in a nutshell would be first, that's about the strategic investment in explainability. So we find that indeed firms may strategically underinvest in explainability in order to escape regulation. So you'd have a rather counterintuitive effect that with more regulation, you have even less explainability, because essentially the firms don't want to give the stick to be beaten with. Okay. So in that case, our advice is to allow for explainability standards, that is, to have at the same time audits on the one hand that ensure compliance, but also it should sometimes come with explainability standards that will make sure that firms don't run for black boxes. And then when it comes to technology neutral versus technology specific regulation, we note two effects. So the first one is that explainability will act as a commitment device for high compliance. Okay, because if I have an algorithm that is super explainable and I can tell it to the regulator, then the regulator will know that it's actually very cheap for me to be compliant and to avoid discriminatory biases on this type of things. So this is quite positive. This should promote explainability, because you want to show the regulator that it's not worth auditing me. Okay. However, it also paved the way for some regulatory opportunism, in the sense that, well, depending on the objective function of the regulator, if the regulator wants to avoid actual misconduct, and he wants to actually be able to prove a misconduct when there is one, then the regulator might be strategic about that and target specifically the firms that are a little bit explainable, because why would you audit a firm that you know is absolutely unexplainable? Okay, so here, when it comes to choosing versus technology, between technology neutral and technology specific, we have to take into account those two forces. One, the commitment device that does force you to do more explainability, but also the regulatory opportunism. Okay, you don't want to attract the attention of the auditor by telling him that he has a chance to actually find out a misconduct if there is one. Okay? And I thought no, that's good. That's right. Okay, so now to the model itself. So we have a firm, so we are doing cost minimization. Okay. By default, we assume that the algorithm misconducts, okay, or at least in expectation it misconducts. So it will choose the level of explainability and the compliance effort to minimize a certain expected cost. I don't know if, yeah, you see that. Okay, so the first term is simply the expected fine that you get. So F would be the fine if you are caught actually misconducting. This will happen with probability 1 minus P, P being the level of compliance that you have to invest in. So with probability 1 minus P, you're misconducting. With probability M, there will be an audit to your firm. So M is endogenous and decided in the next slide by the regulator. And then eta here is the efficacy of the regulator, okay, which is the probability that if it audits you and there is a misconduct, that he will be able to prove that there is a misconduct. Okay, and in particular in this paper, we make eta depend on x, the level of explainability, which just means that, in particular, we allow it to increase in x. So this means that when explainability increases, the efficacy of the audits increases as well. Okay, it makes the job of the auditor easier. Okay, so that's for the probability, the expected fine. And then, of course, there are two costs. One is the cost of compliance, which we name psi, very standard, increasing and convex in P. And so that's the probability of compliance. Okay, and X allows to reduce that cost. Okay, it just makes your compliance cheaper. So the first derivative of psi with respect to x is negative. Okay, you reduce the cost, and you're more effective. The explainability is increasingly more useful when you want a high level of compliance. Okay, so that's for the second term. The last term is simply the cost of explainability. So that's the graph I showed you. Okay, if you want more explainable technology, then you will need to have something less effective, less accurate, and in some way, well, it will generate a cost to the regulator, to the firm, sorry. Yeah, also we allow for the technology to have a base explainability, x0. Okay, just think of it as a number between 0 and 1. It could be 0, actually. So if you don't do anything, then you have a certain level of explainability, just like regressions have an intrinsic level of explainability. A bit of vocabulary, well, terminology. If in equilibrium we find that there is more explainability than the laissez-faire solution, which is x0, then we say there is investment in explainability. If x is smaller than x0 in equilibrium, then we say that there is obfuscation. Okay, so firms actively engage in reducing the base explainability of their algorithm. Okay, so that's for the firm's objective. Now to the regulator's objective. So we choose a regulator who's biased against the firm, okay, just to have the cleanest effect possible. So it's concerned with two costs, one being the social cost of the algorithm misconduct, and the other one being simply the cost of actually running an audit. So the second term here is the cost of running an audit, so which is increasing and convex in M, being the probability of the audit. And then the left-hand side term is the occurrence of a misconduct, which will cause a negative effect on social welfare of K. Okay, we take K positive and large. That's the welfare damage of the technology in the form of discrimination bias, in the form of collusion or whatever you may think of. So this cost occurs if and only if there is a misconduct, which happens with probability 1 minus P, P being the compliance. And the auditor, the regulator, is not able to identify the misconduct. Okay, this happens with probability 1 minus M eta being I've run an audit and this audit has been successful. Okay, so 1 minus m eta is simply situations when maybe there was an audit but it wasn't successful, or there was no audit at all. Okay, so this is what the regulator wants to minimize. Okay. If we don't have questions on the base model, yeah, sure.
I have one on the previous page.
Yeah.
So I wonder, maybe the firm, they choose the algorithm with less explainability because they want better performance. So is it possible we add one more item in the objective function? For example, benefit from using this algorithm?
You mean for internal reasons, you like, as a firm, you like to have explainable algorithms? No, maybe.
Like you mentioned in the first page, that the algorithm is less harder to explain. Usually they have better performance.
Yes.
So maybe that's something we can.
Yeah. Well, in fact, I sort of included in my big C here. You know, which means that, well, I don't really model performance itself, but indeed, if you have something very explainable, then you have something less performant, which I translate as a high cost. C is increasing and convex, so if you go for higher explainability, then you go for higher costs as well, which reflects the initial idea that high explainability means less accuracy. All right, but thanks for the clarification. So yeah, in the C here, you have a lot of things going on, but we aim to capture essentially the fact that indeed the accuracy of your technology decreases with explainability. Yeah.
So here the likelihood of compliance is exogenous?
So ex ante, if you do nothing, then you have no compliance because you don't care about discrimination. That's not your objective function. Otherwise, P is indeed endogenous. But laissez-faire is indeed no compliance at all. Yeah. Okay, so first let's start with the technology-neutral regulation. So explainability would be firm's private information. And the regulator has to keep the same audit policy M for everybody, notwithstanding their explainability level. So we model it as a simultaneous game where everybody chooses its relevant strategic variable at the same time. So quite classically, we get these first-order conditions for candidate Nash equilibria. I'm going to mostly discuss the first one, which is where the tricky things are happening. The firm will choose its explainability level in such a way that the marginal cost of explainability, in the form of lower accuracy, will be equal to the reduction in compliance costs. So remember this term, psi x is negative because you decrease the cost of compliance with explainability. Okay, so marginal cost of compliance of explainability is equal to the marginal benefit in terms of the compliance cost, plus minus the terms here, which reflects the fact that the firm anticipates that it may also help the regulator. Okay, so if you get audited, then you may also, with your explainability, induce more successful audits. Okay, so in particular, by marginally increasing X, you're going to expose yourself increasingly to a fine, which happens with probability 1 minus P times M times the increment in the efficacy of the auditing technology. Okay, so that's the term that, in fact, firms will have to take into account. So it depresses the explainability level that you would optimally choose. Okay, absent this strategic effect, or absent a situation when explainability helps the regulator, you would have the regular, just the first term. Okay, and the other two first-order conditions are quite intuitive. The first one is that you choose your compliance level such that the marginal cost of compliance is equal to the marginal benefit of compliance, okay, in the form of a reduction of the fine, because when you invest in the marginally in compliance, you have this fine F less often, because you get this fine with probability 1 minus P, which is the probability of misconduct, times the probability of having an audit, and 2, that the audit is successful. Last term, also classic, the marginal cost of audits to the regulator must be equal to the marginal benefit of the audit, which is to avoid that a misconducting algorithm is put in place in the market. So that saves k times eta times 1 minus p, 1 minus p eta being the probability that you identify the misconduct. Okay, so the first result we have is indeed that firms may make voluntary investment in explainability, that is x greater than x0, if and only if this big condition is met. Okay. In particular, what we observe in this expression is that if eta prime of x, that is, if the audits are not much affected by explainability, then you will have indeed voluntary investment in explainability. Okay, this term will be small. But if firms anticipate that their explainability policy will help the regulator too much, then they will actually engage in obfuscation. So this is a graphical representation with actually, with functional forms for all of these costs of what's going on in this market, in this setting. So on the x-axis, you have the base audit efficacy of the regulator technology, which is between 0 and 1. And on the y-axis, you have how much it is sensitive to explainability. Okay. So in particular, if the audit technology is not sensitive to explainability, that is, if you are at on the horizontal line here, there is always investment in explainability. Okay, because firms, because they are audits, they want to comply, and therefore they want to reduce their cost of compliance through explainability. Okay, so in that case, that's the standard case in traditional regulation, where indeed you have regulation, so firms abide by the regulation and they invest in self-regulation. As the audit sensitivity to explainability, that is, as the performance of the regulator is affected by explainability, then firms may start to engage in obfuscation, that is actively degrading the quality or the transparency of their algorithm. Okay. So a few corollaries, actually pretty simple and straightforward. The first one is that if you have a regulator that has a base technology, has a technology that has no effectiveness as a statu quo, that is when there is no intervention from the firms, then there is no investment in explainability at all. Okay, you don't want to invest in explainability when the base technology itself is actually completely elude regulation. Okay, so you need a sort of a minimum level of audit efficacy to get this rolling in some sense. Then, second corollary, when explainability strongly increases the efficacy of regulatory audits, there is no voluntary investment in explainability, which means that's our first conclusion, that we probably want to implement minimum explainability standards when indeed the regulatory audits are sensitive to the explainability level of the firms. Okay, so that's for the first set of results we have. Then regarding technology-specific regulation, so here we allow for the regulator to first compel the firms to disclose what is their explainability level. Okay, so the regulator will know in advance what X it will be facing when it runs the audit. So we do two stages. First, the firm invests in the explainability X, and then as a second stage, as before, we have a simultaneous choice of M and P by the regulator and the firm itself. Okay, so in that case, even though we solve it, of course, by backward induction, it's still useful to go by inward or forward induction to just see what changes compared to the situation we had before. What changes is this new term here. That is the firm, when it invests in explainability, will also take into account that indeed, if I invest in explainability, I might affect the likelihood of an audit to my firm. Okay, so whether technology-specific regulation is a good or a bad thing for explainability, that is whether forcing firms to disclose their explainability will promote or not explainability, will depend actually on the sign of this thing, that is how the explainability changes the likelihood of an audit. Okay. In particular, we would like this to be negative. Okay, if you want to promote explainability, you want firms to be convinced that if they invest in explainability, they will be less audited than if they don't. Okay, so we want M prime to be negative. Well, in fact, what we find in the resolution of the second stage is that you have two forces at play when it comes to technology-specific regulation. The first one is the commitment to comply. So this is the most obvious effect. If you invest in explainability, you're basically showing that you have clean hands to the regulator and that you have invested in a way to have cheap compliance. The regulator knows that compliance is cheap for you, and therefore there's no point bothering auditing the firm because it's very likely that it behaves pretty well. Okay, so this tends to indeed put a negative relationship between X and M, which is good for explainability. Firms like not being audited. And then, unfortunately, there is also this effect, the red and the orange one, which takes account of the fact that the regulator also might be opportunistic. That is, if the regulator knows it will face a pure black box, it will not invest in auditing that firm, because it is going to be pretty convinced that something is going wrong, but it will not be able to actually prove it. Okay? So that may push the regulator to strategically target the firms that have a minimum level of explainability, because at least there they can prove a potential misconduct. Very good, thanks. Okay, so same graph as before. Here I'm just showing the difference between the technology-neutral and technology-specific regulation. Technology-specific being when you allow for, you force the firms to disclose their explainability level beforehand. Okay, so we have a similar relationship. What we observe is indeed that the more the audit is sensitive to explainability, the more technology-specific regulation is bad. Okay, orange means here that technology-specific regulation is less good than technology-neutral. So there are situations indeed where it's better not to allow for transparency over the explainability level, because it will push the regulator to be strategic, to be opportunistic, and therefore firms will retract their explainability level because they don't want to be audited in the first place. So there are indeed situations, so in particular when audits are very sensitive to their explainability level. So for example, audits that concerns really the code, understanding the code of and backward engineering what is going on in the code. In this situation, actually, it may be better to simply stick to technology-neutral regulation, okay, because of this strategic behavior of regulators. In particular, what we see also, the dotted line would be the line that you had before that just says whether technology-neutral regulation is a good thing at all. Okay, does it promote explainability or not? So if technology-neutral regulation is good, then technology-specific regulation is even better. However, so if you're in the orange part, that means technology-neutral regulation is a bad thing, and technology-specific regulation is an even worse thing. Okay, so we have a bit of a result that says that if things go well and according to plan and the regulator is not much affected by explainability, then technology-neutral regulation is good, which is intuitive, and technology-specific regulation is even better, which is also intuitive because more transparency generally leads to better efficiency. However, when you take into account this dependency of the efficacy of the audits to explainability, then this is completely reversed. Okay? Technology-neutral regulation is bad for explainability, and technology-specific regulation is even worse. Okay, so that's in fact, our key results. Okay, so this just says in more accurate terms, maybe what I've just said, but indeed, when the audit efficacy is not affected by explainability, which is the standard thing that we study in audit economics, then technology-specific regulation, always outperforms technology-neutral regulation. However, when the fine is too small, which arguably is the case today because we don't have fines for the moment for algorithmic misconducts or very low fines, or when explainability strongly affects the quality of audits and does not strongly affect the cost of compliance, then technology-neutral regulation should be preferred. Okay. So now, yeah, I guess I'm out of time anyway, so I'm going to conclude with the overarching conclusions. So the first one being that if regulators want to promote explainability and avoid black boxes, then they may have to implement minimum explainability standards, especially when their audit technology is very much affected by the explainability level. Also, technology-specific regulation is in general a good thing, unless audit efficacy is very highly sensitive to explainability, which is, well, actually an empirical question to date. And this concludes my talk. Thanks.